Hello, and welcome to the second part of Lesson 7. This is the second lesson in Unit 2B in our Grade 10 academic math class. This is the cosine law. So in the first part, we talked a little bit about the cosine law and why it's a tool that we need now that we've shifted away from right angle triangles. We've already used the cosine law to find a missing side length, given two sides and an angle contained between them. Now we're going to move on to example C here, which is using the cosine law given three sides, and we're going to use it to find an angle. So when given a choice, you want to find the largest angle first. Now this is an important thing, and I want to highlight this because this is super important. When given a choice, find the largest angle first. And again, the hint, of course, is that the largest angle corresponds to the largest side. Again, that's kind of a little bit of our dummy check influence right there. Now, I will say that in a question like this, we've been asked to find angle R, so we don't have a choice. If you're being asked to solve an entire triangle, however, you always want to pick the largest angle first. Now, the reason for this is we're not going to learn about it in grade 10, but it is out there, and it's not just us saying this because this is what mathematicians do. It's because there is something about the acute angles in non-right angle triangles that will lead you to get either incorrect or impossible triangles depending on which angle you find first using the cosine law. If you always find the largest one first, you're always going to be on the right path. You'll find why in grade 11, so hang in there. In the meantime, let's work on this triangle that we've been given here. So we have triangle JER, where we have little j is equal to 5. Let's pop that in. Little j is equal to 5 centimeters. Little e is 6 centimeters. And little r is 8 centimeters. Now it just so happens that given this layout, we know that the largest angle is going to be angle r. So it happens to coincide with the one that we wanted to find anyway. But nonetheless, there you go. So let's put that same information over here as well. I believe little e was 6, little r was 8, and little j was 5. And we've been asked to find angle r. That's this guy right here. So let's get ourselves the cosine law. Now I'll be using the second variation on this, the one from the right side up here at the top, but truly you could just as well use the first one and then just use algebra to reorganize it. This is just me sort of giving you a little bit of a head start on it. So let's get that written down using the letters that we have here. So we know that angle r then will be equal to the cos -1 of, and now we're going to get our numerator here happening, which is j squared plus e squared minus r squared over 2je. And again, as I said at the very beginning of as I said in the first part of this lesson, angle r minus r squared. If we were finding angle j, it would be minus j squared. If we were finding angle e, it would be minus e squared. That's the patterning that you want to remember. So let's do a substitution step now. We have the cosine -1 of, so j was 5 squared plus 6 squared minus 8 squared all over 2 times 5 times 6. Okie doke. Now, you've heard me say before I like to do things all in one step. You've definitely heard me say that because I'm pretty sure I said it in the last video. However, when you're working with this particular configuration of the cosine law, I like to complete the numerator and then complete the denominator. I like to keep them separate, reason being that sometimes with squaring in brackets it can just be a little bit too much, and there's not necessarily a reason to do it if you're just going to put yourself in the danger of making more mistakes. So let's just type in our numerator. 5 squared plus 6 squared minus 8 squared gives us, now we have a -3 here. Is that okay to have a negative numerator? It is, actually. That's part of the reason that we always find the largest angle first when we're working with non-right angle triangles. Our denominator is 2 times 5 times 6. That's going to give us 60, of course. There we go. So we're going to type this thing in. All you really need to know at this point is A, that a negative numerator is okay, and then the second part, which is that it just means that in this context, the angle that we're trying to find is going to be larger than 90 degrees, but that's no big deal. So we have angle r here, we're sidling up to it. Let's type this into our calculator and see what we get. So we have the second function, cos, where we get this piece right here in the display, and now we open a bracket, and we have -3 divided by 60, close the bracket, equals, and we've got 92.8, so that will be approximately 93 degrees. And I kind of squished it in there, but there you go. Okay, so nothing wrong with a negative numerator. It comes out with an angle for r that is larger than 90. Again, that's also okay. Those triangles exist, no problem at all. So we've used the one above where we used it to find a side length given two sides and a contained angle. We've just used it down here when we were given three sides to find a missing angle. And now we're just going to do a whole solve on triangle PQR. So let's jump right in here. So we have triangle PQR. Angle Q is 130 degrees. That's big. Little r is 8, whatever units we've got there. Apparently no units, that's fine. 10. And these other three are the pieces that we are going to find. So let's include these labels as well. So little p and little r. Little p and little r are 10 and 8 respectively. And this was 130 degrees. So for us, which of the cosine law variations should we use here to get ourselves started? I guess the very first thing is to note that this is not a right angle triangle. So we're going to not be using Pythagorean theorem. We're not going to be using primary trig ratios. We can use sum of interior angles still, but we only have one angle so far. So we're going to be using the cosine law. We have two sides and a contained angle. So we're going to be looking for side little q to begin. So let's start by writing that out. Let's change up my colors here. Number 1, find little q. And let's write that right out. So we've got q squared is equal to, now I'm just going to do a substitution here straight up. I'm not going to do a rewrite with just the letters. So that's going to be 10 squared plus 8 squared minus 2 times 10 times 8 times the cos of 130 degrees. Now one thing that we know, of course, is that, or I guess that we just learned, that it's okay if there are angles that we find the cosine of that are larger than 90. We know that it will spit out a negative value. So for us, if you're doing this in steps, again, that provides another opportunity for you to make an error, which is why I suggest you just type this whole mess in and see what you get. So let's do that. We got 10 squared plus 8 squared minus 2 times 10 times, I missed an 8, there we go, times 8 times cosine of 130 degrees equals, and I got 266.846, etc. Again, I'm not clearing that. I'm going to just go on and take the square root of that without clearing it from my calculator, and that will then give me, that'll give me q is equal to approximately, let's get the square root on that thing, 16.33, so we'll go 16.3 units, whatever they happen to be. And let's pop that in. So 16.3. All right, we're doing very well here. Now we need to go and find an angle. So how can we go about finding an angle? Well, now actually we have all three sides of this, so that's looking good. Let's see if we can go get another angle next. It doesn't really matter which one that we go to do, since we have our 16.3. So I would just recommend here going for the next largest one. Sounds good. So let's go for angle P. So 2, find angle P. All right, so we're going to find angle P. We're going to set this up so angle P will be equal to the cos -1. And again, I'm not going to do a substitution this time. I'm just going to do a full-on, or I'm not going to do a rewrite. I'm just going to jump right to the substitution. So we have 16.3 squared plus 8 squared minus, and again, this is minus p squared, right? It has to be if we're looking for angle P here. So I'm going to substitute in what P actually is, which is 10, all over 2 times 16.3 times 8. And again, I'm going to recommend that we do this in steps. So angle P then will be equal to the cos -1 of, and let's type in our whole numerator here. So we've got didn't type that right, 16.3 squared plus 8 squared minus 10 squared equals, so we got 229.69, and we're going to put that over 2 times 16.3 times 8 equals 260.8. All right, so let's type this whole thing into our calculator now. So angle P then will be equal to approximately, so I'm going to start by second function cos, open my bracket, 229.69 divided by 260.8, close the bracket, equals, and I get 28.2, so we'll just go with 28 degrees, give or take there. Okay, so we have our angle P. Let's put that in. That's 28 degrees. And now, in order to find angle R, we can just find angle R by using the sum of interior angles. So find angle R. We know that angle R then will be equal to 180 degrees minus 130 degrees minus 28 degrees. That's going to be equal to, calculator says, 180 minus 130 minus 28 equals 22 degrees. And we'll put that in, 22 degrees. And that is the end. We found all three values. Let's do a quick dummy check here before we get out. So largest angle across from largest side, yes. Smallest angle across from smallest side, yes. So we are good here. Some of you might find the cosine law itself to be a little bit cumbersome. Meaning there's, it's a fairly complicated formula to substitute things into. I will tell you that the next lesson we're going to tackle with the sine law is a little bit more straightforward. It's yet another tool that we can use with non-right angle triangles to replace the ones that we lost by getting rid of the hypotenuse. I do want to point out that the homework here is just written on this page. We're going to be just sketching some triangles, and when you're given a choice to work through these triangles, it's just a reminder here that you want to find the largest angle first. The answers are right there at the bottom. If you have any problems working these things out, hit me up with an email, or you can connect to the video chat in the class. You can talk in person, however it's going to work for you, but reach out if you get stuck, and we'll see you in lesson number 8.